share what our experiences out there, and it's more of a listen and ask questions kind of thing, and just try to each quarter just update with what's going on in the marketplace from either a regulatory perspective or a challenge perspective on projects. And so this first episode, if you will, of this web series, we're going to discuss just dewatering in general, and just the ins and outs of dewatering. We're going to talk about dewatering equipment, all the different types, and the benefits of each one, and the importance of sampling, and really knowing what your sludge consists of. How do we get sludge removed from tanks, ponds? How do we get it to the dewatering equipment to begin with? And then we'll open it up and we'll ask to see if anybody has questions from our conversation today. You can also feel free to ask questions as we're going. We have our great marketing coordinator, Rachel, here that's monitoring the questions coming in, and it's going to be kind of a conversational type of meeting. So it's not going to be a whole lot of structure to it, so we can answer questions along the way. So with that said, I do want to go ahead and thank our first 10 attendees that registered. We sent out some DoorDash gift cards to you. I believe it was the day before yesterday. And so if for some reason you don't have those in your spam box or inbox, just feel free to reach out to me after the call, and we'll make sure we get those over to you. But they should you should have those. And so yeah, I think I'll just go ahead and begin the call today by telling you a little bit about who we are. Our company is Handex Consulting and Remediation, and we've been in business since 1968, roughly a little over 50 years, and we really specialize in industrial dewatering and remediation. Since our infancy, we've always had some sort of play in dewatering, whether it's construction or industrial. But I would be remiss if I didn't also share that we also have a side of our business that just does remediation, and we have engineers and scientists, and we do some of the biggest remediation for a couple states, Florida and New Jersey. We have state contracts with those folks, and Department of Transportation in both states. So it's really great when we get involved with some industrial type of projects that have some environmental complexity, because we can always pull folks from our other divisions over, and it's a really good thing to have in our back pocket. But yeah, so we've really advanced and honed our skills into dewatering in general from an industrial perspective. And when I say industrial, we serve wastewater treatment plants, we serve pulp and paper, we serve energy, we serve refining, and we serve the food processing industry. And so I guess I would just throw out the question there is, what is dewatering, and what dewatering needs are out there? And dewatering can fit a lot of different definitions, but to each industry, it may have its own definition. So in wastewater treatment plant application, wastewater treatment goes through lots of different processes, through clarifiers and thickeners and digesters and that sort of thing. And then you have biosolids to deal with at the end. And so, in their world, they want to have the biosolids dewatered into a cake. So then it reduces the amount of waste that's going out. Obviously, wastewater treatment plants have to continuously run, and that meets a lot of stringent requirements before it goes back out into whether it's going to go back into the retention systems or recirculating systems. So there's a lot of things that are involved in that has to be dewatered. If you take a look at the pulp and paper industry, as part of their process, they have a lot of water that comes out of their processes, and it's got pulp in it, and it's got maybe some limes and some ash and that sort of thing. And so they usually have a series of ponds. It starts out with an initial holding pond, and then may go to an aeration basin. Before that, and it then leads into some sort of natural waterway typically. And so when it comes to sludge dewatering, they have to make sure those ponds don't keep building up, or they could have a backflow into the plant, or their total suspended solids could be an issue on the last point of their polishing. Their polishing ponds is another name they use at the very end, and there's some defoaming and stuff that happens. So there's dewatering from that perspective. In the energy, you have some coal ash ponds that have to be cleaned out, and you also have, and this kind of goes with the refineries as well, you have large separators that collects anything on the property that comes from spillage or rainwater's rinsing stuff down. And typically you have a natural waterway that the runoff would go to, and these API separators, as they're called, would collect this material, and the sludges out of that would need to be dewatered. But then you also have tanks. From time to time, you get lots of tank bottoms built up, and crude tanks or fuel oil tanks and stuff, and so those tanks have to be cleaned out, and you have a lot of waste that's involved with those tank bottoms. And so the main purpose is to minimize that waste. And in some of those industries, you have hazardous waste, and hazardous waste is tough to deal with. It's very expensive. And so the more you can reduce that material, the better it is for really everybody. So, and then you have the food industry. So you have pig farmers, you have chicken farmers, you have, all these different meats and poultry industries that, as part of their process, there are manures, there are greases, fats, all of these things get built up into their, tanks and ponds, and there's different things to help dewater that, to include dissolved air filtration systems as well, and you can even dewater off of those as well, depending on the volume. So it's very interesting how each industry has their own unique challenges, but at the end of the day, dewatering encompasses all of those challenges. And so each one you got to kind of think about differently. And so not one piece of dewatering equipment serves all. And so I think that's what we're going to touch on a little bit here today now is just talk about what different dewatering technology is out there and what's available to the folks on this call. And so Rick, I don't know if you want to cover and go through some of the dewatering technology and maybe what the best beneficial use is for that.
Yeah, so the first one we'll discuss is in the industry itself, you'll hear the term filter press, which is it's a recessed plate and frame, and it's a combination or a series of plates that are within the frame of the filter press, and these plates are recessed between each one with about 1.25 to 1.5 inches of recess, and this is where your dewatering takes place. And each one of these plates are outfitted with different size cloths that are sized up by CFM. And depending on what you're running, will depend on what size CFM cloth you need. We use these filter presses mainly when we have to dry out the cake to an acceptable level when you're dealing with hazardous waste. And that's mainly to try and reduce the haz waste cost for disposal as much as possible. Then on behind that, you have the centrifuge, which can handle multiple streams that are out there when it comes to dewatering. It's probably it's probably the most versatile system that we utilize when it comes to dewatering, because of its capability of handling multiple sludges like that might have paraffin content in it, where a filter press is not paraffin's not friendly to the filter press, so we would look at that. And then behind that, you have the belt press, which is used quite a bit in the paper industry and in the municipal industry. And each one does have their pros and have their cons with them. And what we do is we look at each individual project separately, and we look at it at all angles of what we feel is the best fit for that particular project. And, and some of the things we'll talk about here soon would be the importance of sampling. And that tells us a lot of what piece of equipment we would use just by going through our treatability studies. Filter presses, we all know that it's going to give us the driest cake, but it's a batch system type operation. So the throughput is probably, out of all three that I mentioned, is probably the least throughput is on the filter press. So what we have to do is we have to balance what is important. Is finishing the job faster versus drier cake? Which one of those are more important? The centrifuge, we know on the centrifuge that the throughput, depending on the size, and if anybody knows anything about centrifuges, there's multiple sizes out there in the market. Us particular, we try and stay around the 18 to 21 inch size diameter on the rotating assembly. And everything on a centrifuge is separated by gravity. So that's very important to know what the gravities are on the material we're trying to remove out of the water, out of the wet stream. And then the belt press itself, it does have a high throughput. It kind of compares to a 21 inch centrifuge, depending on the size. Again, that also has different sizes. And I will go back to the filter press. There are multiple sizes on the market for filter presses too. In particular, Handex, all our units are mobile, and we're running about a 3 to 3.7 yard filter press on our mobile units, where our centrifuges, again, are 21 inch belt presses. 1.8 to 2 meter belt presses is what we typically use from a mobile standpoint. So again, back to the importance of each one of those. We rely heavily on the sampling aspect of our business.
Yeah. Well, thanks, Rick. Those are some good descriptions of the dewatering equipment. And, as you can hear, we're not impartial to one type of equipment or another. It really boils down to the situation and what's going to be the best for your project. And so Rick mentioned sampling, the importance of sampling. We often run into situations where, people don't do the sampling that they should, let's just say. And, then they find challenges during the project, and had they focused really on the sludge material and what's best for the project, then they probably could have avoided that. And so one of the things that we do is we collect a sample, and it's usually from, if it's a pond, multiple points out of the pond. So you get really a good example of the different areas of a pond, from the inflows to the outfalls, to see where the sludge changes, the consistency of it, that sort of thing. And not only that, but some of the dewatering equipment will require a coagulant, and then some does not. And so the sample is going to tell us a lot about what we need to use to get that sludge to the ideal scenario for your particular project. And so Rick, I think, would you mind telling the audience just kind of what information do we actually get from what we call a bench scale sample or study to then be able to present the project? I know I just covered a couple.
Yeah, so in that situation, again, I go back to the different varieties of dewatering equipment out there, and a lot of what the sample will tell us. And that could be decided even before we grab the sample. The first thing, if a customer tells me, well, I got a tank that's full of paraffin, well, I know for sure that a belt press or a filter press is not going to be the ideal piece of equipment. So we will lean more towards the centrifuge, and we all know that more than likely it's going to take heat, and we simulate that in the lab. We want to know what the density of the material is, and that's given to us. We want to know what chemistry we have to use to ideally separate the components of that sample, be it two-phase liquid solids or three-phase liquid solids, and that one of those liquids being an oil. So we can also do three-phase separation when it comes to processing with centrifuges, two-phase or three-phase. And usually we see that in the refinery industry when we're looking at three-phase operation. The other thing we look for is, again, like I said, the chemistry. We want to know on the back end what results what we're gonna end up with. Now, understand that we're working in a controlled environment when we're in the lab, but it gives us some close indication of what we can expect in cake moisture, cake solids, dry tonnage, wet tons, and we can furnish that to our customer when it comes to disposal. Now, what we do not do in our lab when it comes to treatability stuff, and this is all for the process itself. We can't tell you, what the hazard components are. We don't do, testing for chemicals or anything like that, other than what we're going to use in that. So,
Like a T-clip.
But we can do T-clips, but we would have to sub that out. But all the information we run in our lab is to tell us what we can expect from a dewatering operation.
Cool. Very good. Very good.
And that test actually, when it comes to chemistry, it gives us all the way down to the parts per million of chemistry that we're going to have to use.
Yep, and that's very important. I think there's some examples on your screen, because then we get to know how many tons we expect to deal with on the back end for disposal, what the the percent solids is of that tonnage, volume by weight, like you just said, polymer usage, all those things, and all those things play into the final cost of your project. And so, for example, we could probably, unless it's got paraffins and oils and stuff like that, more than likely use any piece of equipment to get it to pass paint filter test, right?
Yeah.
So, but if you're dealing with a hazardous waste stream, you don't want it just to pass paint filter test. You want it to be, as concrete dry as you can get it, because we all know hazardous waste disposal is a lot of money. But your particular project, you may be more interested in time. So we may get the piece of equipment that's going to get it to pass paint filter test, but be as fast as humanly possible. So we outweigh all those things.
Yeah, and the other thing we add value to, you know, depending on where your disposal outlet is gonna be, you know, I know in the refinery industry, when you're dealing with cat fines, you know, a lot of that material is gonna go to what we call cement kilns, and the BTU value of that material has to exceed a certain BTU, and we can also give you that information when it comes to that, so you can, you know, you can decide if what we're offering to you or is going to give you what you need on the back end for disposal. But, you know, mainly what we're trying to do is see exactly what we have to do that least pass paint filter and take it from that point on. If we can't pass paint filter, then basically your dewatering is not doing you any good.
Mhm. Thank you. Well, so the next topic that we had on the agenda was, okay, we've got this material we want to dewater. Now, how do we get it from point A to point B? And really that depends on, you know, what is point A? Is it a tank? Is it a pond? Is it a, you know, a clarifier or something similar to that? And so really there's basically two ways to do it. There's multiple ways out of those two ways, but the first one being a some sort of hydraulic pump system. And so, you know, a hydraulic pump works very well in tanks. You can pull stuff to the pump. It can be done by man. It can be done by man and fire hose. It can be done by man and squeegee. It can be done mechanically, you know, by crane, or just depends on the scenario. And then the other thing is to dredge. And when I say dredge, there's a couple different ways to dredge, and there's hydraulic or mechanical. And your hydraulic is going to be kind of your dredges that sit on top of the water, and they either can run off of electric cables, and it's set up on a cable system, and you basically set anchor points on each side of your pond, and it runs and dredges at a certain level in a straight line across that pond, so you know exactly what you've dredged, and then you can drop it down to another level, and basically it's just these little, we call them cutter heads, that will turn, and there's a pump that sucks right off of those cutter heads, so there's really little fluff that releases, and so it keeps it in pretty good line, pretty consistent. And then there's also kind of free floating dredges that can be called spud dredges, and where they have stakes and they kind of do a spinning motion and they dredge like this. And then from a mechanical method, you can use long reach excavators, and you can scoop sludges from, you know, under the water, and those can be used typically on barge systems if you're doing sediment dredging, or from the banks if you have to kind of go around ponds and scoop from the banks, and then that material can then be dropped into dewatering boxes and that sort of thing, for it's, you know, the sludge is then moved to some sort of dewatering equipment if it needs further dewatering. And so that's kind of how we look at it, and we're versatile in all the different methods. And you know, that may be a topic that we're going to end up doing in another future webinar, just the different dredge methods. I think you saw on the screen just a few minutes ago that we have a piece of technology that we like to use in-house because it's very versatile. You can get it on very tight spaces and small ponds, but that's our electric remote control operated dredge, and that's cable driven. And I don't know, that's kind of my round table on dredges.
Yeah, you kind of hit on all points there. You know, I'd go back to, you know, the tank extraction, you know, when you're extracting material out of tanks. If anybody knows that on tanks, you know, it's very important that you limit the confined space access when it comes to personnel. There's a lot of automation technology that's out there to be used, which we employ quite a bit of that. There's if you have a tank that has quite a bit of solids in it, too much to open a manway and put people in or put automation equipment. There's what we call tank sweep technology out there, and that's cold tap mainly on the manways, and that's utilized to what we call fluff and stir, fluff the material up, stir the tank, pull it out as it's being stirred up, and then sent to the dewatering equipment. So, we talk about dewatering here, but we have to get it out of whatever's holding that material in order for us to dewater it. So it's very important that we look at the front end as much as we look at the back end.
And we use a lot of mixed tanks, right?
We use a lot of mixed tanks. I mean, for this material to consistently be fed to any one of these dewatering equipment, it has to be homogenized. It has to be consistent when it comes to solids, loading, and so forth. If you have sporadic solids loading to a centrifuge, and you don't have an operator there watching the centrifuge itself, it doesn't take long to pack one of these units off. So it's very important that the homogenation and the consistency of the material is constant going to each one of these pieces of equipment.
Yeah. And you speak of paraffins.
And not to cut you off, but and a lot of this is when we're chemically treating our sludges, we're doing that on the fly, as it's being pumped to the unit. So if anything changes within the consistency of that feed, that sludge going to the unit, then that also affects our chemistry. So we either have to slow down, speed up, depending on. So that's why mixed tanks are very important to us when it comes to dewatering.
Mm-hmm. And again, that goes back to the sample too, right?
Right,
so
it goes back to the sample. Yeah.
We need to know what we're injecting those mixed tanks with, right, and at what rate.
Yeah. And that's very important. So we need to know. So one of the things we do is when we do sample, like Ben said, when it comes to a pond, we'll sample in multiple areas, and we'll look at 4 or 5 of those samples as individuals. And if we see they're pretty consistent throughout the pond, we'll composite those samples, and that's what we'll run. And the lab will tell us our solids concentration by 2 ways. They'll tell us by weight and they'll tell us by volume. And when I'm looking at a process, when it comes to, let's say, centrifuge, I look more at the volume because it's all about solids loading, and conveying capabilities of a centrifuge. So the rule of thumb when it comes to centrifuges, 25 to 35% by volume is a pretty good number when it comes to environmental sludges or industrial sludges. The oil field, which we don't dabble that much in, is a totally different animal when it comes to utilizing centrifuges.
Very interesting. So again, that sample we can't express enough is very important part. So make sure, if you're using a company for something, no matter what dewatering technology that they're using, make sure that they're really analyzing your sludge and they're able to come to you with a plan ahead of time, or else it can get into some tough situations.
And I just want to say for the individuals that's on the webinar is, we can receive a sample 2 ways. We can receive it from you, or we can go out there and collect a sample ourselves. And if there's any instructions needed when it comes to you sampling it, we can definitely send you those instructions after we do what we need to do looking at the project.
Mm-hmm. Yeah, very good, very good. So that is kind of an overview of who we are and what we do from a dewatering perspective. I feel like now's a good time to just open it up to see if anybody has any questions that they want to have us answer for you. If there's any scenarios that or situations that you're dealing with that you could use some advice from, we'd be happy to answer anything you guys have today.
Get on the second on the questions since they have to type them.
Yeah. All right. But again, we appreciate everybody joining today. It's not lasting too long, about a half hour here. And one thing that I will just say as we're waiting for any questions that may come in is that we're going to send a survey out after the call. And, if there wasn't any questions that you felt comfortable asking here live, feel free to ask during the survey. Also, feel free to give us some suggestions on maybe future topics that you would like to hear about. And then also, if you would like to have anybody from Handex, discuss with you about your project privately, or, need some consulting, we'd be glad to do that for you. We'd be glad to, do a free site visit to you and take a look at your project and see how we can assist.
So Camille asks, what are the cons of a centrifuge?
The cons of a centrifuge, when you compare it to a filter press, is the solids content. So to give you a comparison, when you're looking at a filter press, and again, it all depends on what you're running, you can get into the 25 to 35% solids content on the cake, where on a centrifuge, give you an example. Not sure what industry she's in, but let's just talk biosludge. When you're talking biosludge, a filter press is going to give you well over 25 to 30% solids content, where a centrifuge might give you 21 to 22 at best. But usually you see about 18% solids content, and this is all by weight on the solids coming off a centrifuge. The other thing is, a belt press has a lot of moving parts on a belt press, but it's very slow moving. As far as bearing wear, filter press practically has really no moving parts through the operation, other than the pumping. When you're opening the press, you're using electric over hydraulic, where a centrifuge is the rotating assembly weighs about 3,500 pounds on a 21-inch unit, and it sits on two pillar block bearings that are spinning where this unit's spinning about 3,000 RPMs, and that varies from 1,000 to 3,000. So you do have a lot of wear and tear, or you can expect some wear and tear. And on the internals of a centrifuge, you have what we call the scroll, the conveyor, and depending on the abrasive content of the material we're running, can have a lot of wear on the scroll itself. So that's mainly the two cons of a centrifuge. And the third con is the power requirement that is needed to run a centrifuge. Your electrical requirement is fairly high on that compared to a belt press or a filter press.
Okay.
Yeah. Sorry. Great question. I was just going to say, every piece of technology has cons and they have pros. And again, it really boils down to what is your project.
But I do want to stress the pros about the centrifuge. Out of all three is the versatility of that unit being able to run multiple facets of different sludges. It's more forgiving than what the belt press and the filter press is, and the throughput is a lot more than what you're going to find on a filter press, and in some cases a lot more than what you're going to find on a belt press.
Okay.
And it's going to definitely give you drier cake at the back end than what a belt press will, and it's also going to give you better clarity and capture efficiency than a belt press.
She said thank you, so I think that answered her question. Ralph asked, which method is best for oils and grease sludge?
Centrifuge.
That was an easy one.
Yes.
Yep.
And the reason for that is because the grease It's very sticky. And the belts that you have on a belt press, you know, as we all know, has to have the porosity in order for the dewatering to take effect, and so does the filter press. And when you're dealing with a lot of grease or a lot of paraffins, very thick oil, that affects the throughput of those. It's what we call blinding. It has a blinding capability of those two filter medias. So the centrifuge is definitely the best. And when you're talking about oils and grease, we all know grease has a melting point, where if we have to use heat, depending on the flash point of the material we're using, we can heat up centrifuge material that's going through a centrifuge up to 200 degrees if we want to. The bearing components on a centrifuge are capable of handling that. But what we try to do is we try to stay within the flash point of that material, and the hotter we can get it, the less viscous it will be. And what I mean by that is the thinner the material, the easier it is to run. Where on a filter press, because of the plates, we are limited to how high we can bring our temperature on that material without warping or melting plates.
That's a good point.
Okay. Camille has another question. What kind of maintenance can you look forward to with this centrifuge?
Again, it depends on what process we're looking at, as far as that goes. It can range, and I'll give you a dollar value. I mean, it can range from $8,000 a year to $50,000 a year. You know, if you have a back drive that goes out and you got to replace a back drive, and when I'm talking about that, I'm talking mainly about a hydraulic back drive, a Viscotherm, that can run you $50,000 in order to repair or change it, $30,000 to $50,000. So it does vary as far as that goes. Now, your preventive maintenance compared and that's more of repairs. Now, when you're talking maintenance, preventive maintenance, it's really it's using grease. So your pillar block bearings, which are on the outer part of the centrifuge, are greased daily. Probably 3 or 4 shots of grease daily. Your internal bearings, which rotates the scroll, which is in the bowl itself, that's greased once a week, and it can take 15 to 20 shots of grease.
So in like summary, the really the just day-to-day maintenance is grease.
Yeah,
But if something major does break, it can be quite expensive.
it can be quite expensive, yes.
Yeah. And then typically, just so you know, most of the times you get a year warranty on a centrifuge for anything major, and so that's all covered. But
yeah, we have some centrifuges that have been in service for a year, and we've seen we haven't seen major repairs on it, but it's in a biosludge industry. Like I said, it depends on what you're running through it. As we all know, biosludge is not abrasive material. It's probably some of the easiest material to run through a centrifuge. That's why the maintenance is down. I don't know if we have any oil field people on here that do oil field processing. That is very hard to process. It's very hard on a centrifuge, but that's what's used in the industry. And you can be repairing a centrifuge every 120 days, doing a complete overhaul on it.
Yeah.
Okay, she said thank you. Just seeing if there's any other questions.
Okay. All right. Well, looks like that's probably going to be it for us today. We appreciate the questions. I hope we answered them correctly. Again, if there's any more questions that you think about down the road, you guys have my email. You can reply to the survey. We'll be glad to help you at any time. This is what we do every day. Just feel free to bounce some advice or, you know, ask for advice or bounce questions off of us. And, yeah, so expect the survey to come out afterwards. We appreciate if you fill that out. We also appreciate it if you follow us on LinkedIn, and we can do anything for you. We appreciate it. All right.
Okay,
Any more questions?
nope, they said thanks for the time and sharing our knowledge.
All right. Well, thank you very much. Y'all have
Thank
a
you.
great day.